started with some theory, and we talked about hardware. I forgot to mention David runs a company that manufactures ASICs. Still runs a company that manufactures ASICs. And now we're going to go to Matt Corallo, who's going to talk about software, I presume.
Kind of. So my background, I've been contributing to Bitcoin Core since 2011. Now work for Square Crypto, a new initiative within Square, to contribute to and promote open source cryptocurrency software and adoption. But I've also worked a lot in the mining space, in the mining software space, and this is maybe to some extent a little bit of a counterpoint to David's talk, more of a propose that David's talk is more of an open research question than something that is as solved as David is proposing, and then kind of talk a little bit about kind of the broad strokes of, I think, the end game of what David's model would be. But first, I'm going to define a term, and I kind of assume that there exists a better term for this. And so I would welcome someone throwing something at me and telling me what the term actually should be. But for lack of a better term, I'm going to call this the consensus group. And specifically, this is just the group of miners, stakers, whatever, who is required to censor transactions. So traditional proof of stake model, you have a third of your stakers, or traditional consensus model, you might have a third of your consensus participants can censor transactions. They can, of course, cause other liveness failures, not creating blocks, etc. But specifically, they can censor transactions. And obviously, in Bitcoin, this is half of the mining power, 51%, if you will. This is true even in the face of selfish mining. So selfish mining does not allow you to censor, it just allows you to gain more profit, which maybe in the long term puts your competitors out of business, but it doesn't allow you to censor. So that's an important distinction. But so kind of this concept of building this consensus group and making it decentralized is ultimately why we're all here, right? So Bitcoin was not unique in the sense that it didn't create a new sphere, a whole new concept out of whole cloth. There were many attempts to create digital currency, online currency, money for the internet, digital cash, whatever you want to call it, in the 80s and 90s, died off a little bit leading into the early 2000s, and has since been revived. But all of these systems did not achieve their initial goals for one reason or another, right? And so the best known thing that grew out of this sphere was, of course, PayPal. PayPal is a very successful business, but did not achieve its initial goal of building this great digital money for the internet, because ultimately now PayPal is best known for closing accounts and censoring people and not doing business with parts of the world. And that's fine, they're really successful about what they do, but that's kind of not where they started and not where that whole ecosystem started. And so Bitcoin kind of grew out of this and said, okay, well, if we take this model of we have this trusted third party and we replace it with what is hopefully a highly distributed consensus group, and make it so that they are hopefully distributed enough that they can't even coordinate effectively, then we have a system that might actually achieve all of these goals we had in the 80s and 90s and build this great thing that might be this kind of censorship-resistant money for the internet. And so, that's kind of where we came from. And now, at this point, we've kind of diverged a little bit into two major research areas for how to achieve this initial goal. So if we take that this is our initial goal, at least. So obviously, the kind of more modern one and the more hip one is proof of stake, right? So proof of stake has a similar goal of we want to take this consensus group, this group of stakers, this group of people who hold tokens, who have money, and make them our consensus group, and hopefully that's decentralized enough to build a censorship-resistant money. The answer is it's not, right? There's been really great research in the last 5 or 10 years on trying to determine wealth inequality and the distribution of wealth within human societies all throughout human history, all the way back to ancient Mesopotamia. Right, and there's all the conclusion of, a lot of that research focuses a little more on how much has wealth inequality improved over the years? Has it improved? How far can wealth inequality get? How bad or good could it possibly get? But all of it also has largely concluded that wealth has always been highly unequal at various levels, but highly unequal. And if we look at kind of today's economy, ultimately wealth is centralized in a handful of large corporations. And a handful, maybe 100, maybe 50, what have you. But ultimately, if you imagine a proof-of-stake system where your consensus group is somehow proportional to the money involved and the money invested, then the limit of what you can do is a third of these large corporations. And that's fine. This is a fine model. I don't mean to imply that this is a terrible model that we should never consider. In fact, it's a great model. That's why Libra is trying to build on this model, right? Except it's much more explicit and much more of a, if this goes wrong, I can sue them, than I'm going to kind of see what happens and have informal agreements and not have contracts. And ultimately, I think, if you go to the extreme of David's kind of model here, where we try to play games with centralized miners and large central parties who are ultimately able to censor transactions, then Facebook Libra is in fact a much better model, right? Because we have very explicit parties who are running the system. They are going to have the same set of eventual regulations as any other group of parties who are controlling a system. If there is only a handful of them, it's very realistic to regulate them in much the same way that people are planning, or governments around the world are looking at regulating Libra. And so we should just go with that model, right? And of course, proof of stake and Libra and a lot of these systems end up looking very similar in terms of the consensus algorithms they use, and a lot of the research ends up looking very similar for a reason. Because ultimately you end up with a handful of entities who are running the system. And I mean, we've seen this degrade on some of the existing deployed proof-of-stake systems, especially the kind of delegated proof-of-stake systems, where they've already degraded to 16 or whatever entities who are controlling the system and are getting sued because they're misbehaving, what have you. You might as well just slap a contract on it and hopefully it's easier to sue them. So that's the state of proof of stake. It's maybe a little bleak, but I think Libra has some benefits to society, and that's great that people are working in that space. Proof of work, obviously, is even bleaker, right? So we just saw David's talk about how current proof of work systems are essentially centralized in one, maybe two companies. That's obviously not ideal, and if that were going to be our outcome, I might agree with David that, well, I might disagree with David and say, we should actually just all go work on Libra. Why are we bothering with this? And we should be willing to walk away if our initial goals are just wholesale not being met. But I'm going to have to disagree with David a little bit here. I think the jury is still out. And so I do have some calls for research that I'm going to get to. There's some stuff that I would very much love people to write more papers about. But first of all, let's separate miners and pools. Right, so today, pools are hilariously centralized in Bitcoin, Ethereum, what have you. You're looking at one, maybe two companies who control most of that space. And that seems to be the way that market's going to develop. It's the way the market's always been. Okay. But that's not necessarily true of the underlying miners, the underlying hash rate, the underlying farms, etc. And for the purpose of our consensus group, it might not matter. So today, obviously, the consensus group is not the miners, it's the pools, right? The pools are the ones selecting transactions, they can censor people, they can pick what block they mine on, etc. That is not at all inherent in a pool. That is an artifact of the current protocol design. So historically, there have been other protocols. So there's been distributed pools. If you're Googling P2 pool, was a concrete instance of this that ran great. It had many usability problems, but they weren't necessarily protocol issues. That worked great. There's been some effort to revive that recently. We'll see how far that goes. Bob, if anyone's curious, they can talk to Bob. He's been working on that a little bit. There's also additional work that I've been working on called better hash, and more recently Stratum v2, which is a redo of the existing mining protocols, such that the end miners, i.e. the mining farms, the operators of the hardware, are the ones who select the transactions, they're the ones who construct the block template, and they're the ones who do the only pieces that the Bitcoin network cares about. They just don't handle the payout, reward splitting, all of the kind of businessy things that you don't mind the pool running. Right? And so from the Bitcoin point of view, that would shift the consensus group back to the miners and not the pools. All of a sudden, the network cares much less about the pool centralization and much more about the mining centralization. And so this is a admittedly much too optimistic view, but actually if you take the slush pool statistics of their hash rate on the basis of the different user accounts who have hash rate on slush pool and the distribution thereof, and you project it onto all of the other pools, that's the graph you get. Right, so that's actual data. It's optimistic in the sense that slush pool's client base is going to be a little more distributed than some of the other pools, and there may be some miners who are on multiple pools, but it's probably within an order of magnitude of how distributed you might expect the actual mining market to look. So I disagree. So this is admittedly an area for future data, for more research. We don't have great visibility into this. As David said, if you take all of the public claims of how much hash rate different farms have and you total it up, you might get something like 10x the total size of the Bitcoin network. So obviously public claims have to be taken with a very great heaping spoonful of salt. And so more research there would be very welcome. So that's kind of an open question about how decentralized are things actually. As a kind of structural concept, you'll note, of course, the mining centralization is highly sensitive to power costs. So this has been referenced a few times. Obviously, if you have a 10% better power cost, you're going to have a huge, much larger chunk of the Bitcoin network than all of your competitors. But this is predicated on the assumption that you can grow as large as you possibly want with still 10% cheaper power. And that is very clearly not the case in most power markets. So as the mining ecosystem has continued to develop, we've seen a few trends. It's been shifting out of China, right? So China historically, a lot of the way miners got cheap power was various backroom dealings that were pseudo-legal depending on which governments you were asking, sometimes outright stealing power, etc. We've seen more of a shift towards areas with hydropower was kind of the first major shift. So that's Washington State, that's Canada, that's Siberia. And we've seen kind of a continued shift towards areas that just have excess power, right? And this kind of brings me to the second point is that interruptible power, right? Power markets are much more complex than simple cost. Bulk power markets regularly go negative, right? You can be paid to take power off the grid if there is excess power. This is not unreasonable because power plants cannot simply turn the switch and turn off. If you imagine a nuclear power plant, you cannot turn the switch off. The things are going to keep going and your reaction's going to keep running and you've got to do something. So interruptible power is free, can be negative, but is only available in reasonably small quantities and only on certain time frames. Often you don't know when you're going to get power, but this is ideal for Bitcoin mining because what do you care? You only care about the cost of the power. There are some hardware concerns with this. Current hardware would not kind of survive if you toggled it on and off too often, just because of, frankly, poor design of the hardware. This is something that could be resolved, but is not realistic today. But again, as we look to the future of proof of work and look towards what would this market look like if it continues to develop and continues to grow, these are interesting questions that we should be asking. And it's not just, can you get cheaper power? It's, how do you find cheap power, right? We saw the president of Belarus made an offhand comment that might or might not have been a joke about mining with excess nuclear power at a state level. Right? Because they have a bunch of nuclear power plants. Again, you can't turn them off. If you've got excess power, you might as well mine Bitcoin with it, right? So as we look more towards green solar, wind, and nuclear, as we look more towards those kinds of energy, you see a very, very different power market than you saw 10 years ago. And that might have a very large impact on proof of work. But mostly, this needs more study. Please write papers about this. Writing papers about the structure of these markets and how they play into proof of work is really interesting, and largely I haven't seen too much in that vein. I know some about it, but I'm also not a miner. I don't run mining farms, and I haven't spent a lot of time digging for energy deals and looking at this. So, of course, I briefly wanted to mention kind of some of the other models that people have been talking about, aside from just proof of stake and proof of work, or of course more centralized permission chains. There's always more research needed here, especially if you phrase it in terms of kind of the initial question of how do we build a decentralized consensus group. There's continued research attempting to do proof of storage, proof of kind of wasted hard drive space. It seems promising. At least I think most of the popular incantations of it depend on secure proof of elapsed time, which also seems difficult, although there's actually really good ongoing work in that space, but seems difficult to make not optimizable. So I don't mean to imply that proof of stake and proof of work are the only two possible ways we might achieve this initial goal, only that those are the two kind of well understood models that exist today. So yeah, that's all I wanted to say on that. I did wanted to mention really quickly, and Neha's going to kill me because this is unrelated, but I wanted to mention it anyway. I want people to do research on payment channel network privacy because the current designs all use onion routing, and there's arguments that this might provide privacy, but we don't know. Obviously, there's the standard onion routing timing correlation attacks, but there's also, on top of it, specific to Lightning and other payment channel networks, there's balance discovery attacks where you might be able to map out the entire network's instantaneous balance. How much does random failure and probing protection actually solve that problem? We need formal academic papers, and I'd love to talk to you about that offline.
If there's one question for Matt, otherwise we're going to move into the discussion portion of this. You can ask questions for everybody, so David, go on here, and Matt as well. Yeah, go ahead, ask your question.
So with Stratum V2 and BetterHash, love that work, by the way. That's primarily it helps mine tools because from what I understand, the miners themselves do like the full node.
Yeah, I mean, there's only weak arguments for it actually helping mining pools directly. It potentially can improve your orphan rate ever so slightly because you have, instead of having the block, the latency of block broadcast go from the ASIC to the pool and then out to the network, you can go instantly from the farm out to the network. That is highly dependent on the farm's internet connection. Many farms are in strange locations that don't have good internet, and so it's a little bit of a weaker argument there. But for those in, for example, Washington or Canada, or to some extent Siberia, you could actually argue that that's a reasonable win just because you actually have reasonable internet there and you can get a little better, minuscule but small shavings on your block propagation latency.
But what if the model of mining changes? What if like nice hash becomes the standard and it becomes marketplace of hash rates rather than a mining pool per se, right? Because nice hash is a mining pool, but instead of you can connect to any
Right. Yeah, I mean, I don't think so. Obviously, some people who are mining on NiceHash are purchasing hash power in NiceHash specifically to mine a given template. And so Stratum V2 and kind of the concept of the farm running a full node would break that kind of purchase premium that you see sometimes on NiceHash. But aside from that, I think it's kind of tangential.